Okay, so we're going to go over how to find the surface area of a triangular prism. Okay, now this is a triangular prism, and surface area is actually the area of every face of an object. Okay, so we're going to talk about the faces. First of all, they call it a triangular prism because this is usually the main face they talk about. It's the shape of a triangle. So we'll need to find the area of that. But because it's three-dimensional, there's also another triangle that's a little harder to see. It would be considered on the back end from the angle we're viewing this, right? So already we're looking at two triangles, okay? So we know we have two triangles in this. And then we also have three more faces, okay? We have this large face here, which is very easy to see, okay? It's facing us, so that's a large face. And what shape is that face?
Rectangle.
That's right, it's a rectangle. We also have the face on the bottom here, a little more difficult to see. What shape is that?
Rectangle.
Yeah, and then we have the face that would be considered on the other side. And what shape would that be?
Rectangle.
That's right, so we have three rectangles involved. Altogether, there's a total of 5 faces on this object, okay? So that means we're going to have to find the area of 5 different objects and then put them all together, okay? So a lot of times what they'll do is they'll even draw a web. Have you ever seen a web of a large object? Yeah. And what they'll sometimes do is, how would you do it of this? We'd have just a triangle at the top and then a rectangle. This would be kind of the middle. Another triangle, and then you'd have a rectangle on each side, right? This is our web of it, a rough sketch of the web. From this information, we know that this is 6, this is 6, and this is 6. Those are the measurements of the sides of the triangle. And we know that this distance here is 30.5. Now, the triangle, first of all, in order to find the area of a triangular face, we actually have to find the height of the triangle, okay? We need to find the height of the triangle. And we're going to have to use some Pythagoras theorem to do this. Okay? Now we know if we draw a line right through the middle, we make a right angle triangle. And if we draw a line right through the middle, how much is half of this, if that's the middle? How far is that?
3.
3, that's right. So in other words, we have to use Pythagoras theorem. We know the hypotenuse is 6, and this is 3, that's right. We need to find this height, right? We don't know the height in order to find the area. Do you remember doing Pythagoras theorem? It says a squared plus b squared is equal to c squared. Well, c squared is the hypotenuse. That's 6 in this case. We're going to call h our a. So h, which is the height squared, plus this will be called b, and this has to be c. Okay, 3 squared is equal to a hypotenuse. The longest side is 6 squared. Well, we need to isolate h. So I'm going to move 3 squared, or actually, sorry, I'll equate them first. We have h squared is equal to, not equal to, plus 3 squared is 9, is equal to 6 squared is 36. Well, we move 9 to the other side, and what does it become? If it's positive here, when we move it over, do you remember what it becomes?
Negative.
Negative 9. And we subtract 9 from 36, what are we going to get? 27. Okay, that's 6, yeah. But we're not done. Is that what the height of this triangle is? Is it 27?
No.
And that's way too large, right? The hypotenuse must be larger, so that doesn't make sense. What last operation do we have to do?
Division.
Not division. If it's squared, the opposite is the square root. So we square root the sides, okay? So h is equal to, and we got to use our square root. You've used this on a calculator before, square root?
Yeah.
5.19. 5.19. So the height of these triangles are 5.19 centimeters. Okay, that measurement with the base will help us find the area. Okay, what about these rectangles? Well, we have their heights, you could say, but what are the widths of them? How do we figure that out? Well, it turns out the width of this is directly proportional to the side length of the triangle because they line up evenly, right? So how long was the side length?
6.
So that means the width of this rectangle is 6, which makes sense, right? Because this one here is 6, and again, this one here is 6. And the reason they're all the same is because it's a special type of triangle, okay? It's equilateral, so 30.5. So now we have the measurements of everything. So let's figure out the two triangles. Now, because the two triangles are identical, which they usually are for a prism, we only have to find the area of one of the triangles, or I'll actually draw a shape there, area of a triangle. Well, we know that's the base times the height, what? Divided by 2, right? What's the base of one of these triangles?
6.
That's right. And what do we find the height to be? I'll scroll up so you can see.
5.19.
That's right. 6 times 5.19 divided by 2. So that's going to be the area of one of the triangles. So 6 times 5.19 divided by 2. 15.57. 15.57. That's one triangle, right? So let's keep that in mind. One triangle. Let's do one rectangle. The area of a rectangle. How do we find the area of a rectangle?
Length times width.
Yeah, or base times height, length times width. They're the same thing. What is the base of one of these rectangles?
6.
And the,
yeah, 6.
and the height was?
30.5.
Perfect. So for one rectangle, the area is equal to those numbers, 30.5 times 6, 183. Okay, 183. But what did we say? How many rectangles were there in total and how many triangles? Do you recall? If we scroll back up to the top here.
3.
3 rectangles and
2 triangles.
so instead of carrying out this process, we see here, instead of doing this times 2, doing it twice over, or this 3 times, we can just multiply the answers by those. Okay? That would be like a fast way to do it. So we know both triangles. We know we have 2 triangles. So the surface area is equal to 2 times the area of a triangle. So here's our triangle, which is 15.57. Plus, there's 3 rectangles and they're all identical. So 3 times 183. And that was the areas of our rectangles. And the addition is because we have to add all of these values together to find the surface area. So the final surface area here, 15.57 times 2, 31.14, plus 3 times 183, 549. And then we add these two values to find the total surface area of the rectangular prism. So we add those, plus 31.14, 580.14. And this was all in centimeters, and because it's area, it's centimeters squared. Yeah, volume would be cubed. Okay. So it's a tough process for surface area of a triangular prism, especially if they haven't given us the height of a triangle. There's quite a bit of stuff to figure out.